Hello, Tom again, and in this video what we're going to do is add some relational operators to the Cartesian point class. So where I'm at right now is, again, I'm in class program. We've gone through the various different parts and we're at part 5 now. So we're going to be ultimately overloading less than or equal to, greater than or equal to, but for the moment, I just want to code this method as if they already exist. So let's create two Cartesian point objects. Um, I'm going to call them point A and point B again. I'm going to make them different. I'm going to make one of them, they're both 3, 4, but one of them's going to be -3 and 4. Okay, so the reason why I've picked these particular ones is although they're different points, they're the same distance from the origin point, 0, 0. We'll show their hash codes just like we did in the previous video. In this case, because they're the same distance and hash code is based on distance, even though they are different points, they're going to have the same hash code. And I just wanted to give you the opportunity to see that. And then next, we'll test each one of these operators with an if statement. Okay, so testing less than operator, we'll use a little if statement. If A is less than B, we're going to, write to the console A is less than B. Now you'll notice as soon as I put that in, I'm getting a warning. Okay, operator less than cannot be applied to operands of type Cartesian point. Okay, and so it doesn't know what less than means, and we actually have to think about that. What makes a point less than another point? It's kind of hard to say. There's different ways you can actually define that. So we have to actually think about how we're going to define that. All right, so it's not even going to let us do it. We better add an operator, less than operator, to our actual Cartesian point class. Expand this window a little bit and open up Cartesian point. Okay, in Cartesian point, I'm just going to scroll down a little bit more until I get to this one here where it says determines if a Cartesian point is closer to 0, 0 than another Cartesian point. That's what essentially I'm going to use to define as being one point being less than another. Okay, so underneath that comment, let's code the less than operator. So public operator, it's static, as operators always are. It returns a Boolean. It's called operator less than, and I've defined left and right. It's a binary operator, so I have two operands, and I've called them left and right. Okay. So I want to figure out, I'm going to do this based on the distance from the origin. That's what I've decided to do. Okay, I already have get hash code, which allows me to do that. So I'm actually going to, and this is a little bit unusual, but I'm going to use the hash codes for determining this. Okay, so I'm going to return left.hashcode. If that's less than right.hashcode, then that's what it's going to return. If it's true, it'll return true. If this is false, it's going to return false. Now again, this is kind of unusual, and it's based on how I've actually determined the hash code. If I determine the hash code using a different method, this might not be valid at all. But for the purposes of what we're doing, it's a quick and simple way to determine whether one point is less than another. So let's try that out. Let's go back to a program. We'll save everything here, and we'll try running this. Oh, there's a little bit of a problem here. I will have to, what is the issue? Oh yeah, I forgot about that. So in C#, in C++, it lets you do this kind of thing, but in C#, if you overload the less than operator, it forces you to also overload the greater than operator. Okay, so I don't have any choice here. I can't run my program until I actually do that. So let's scroll down into the code. It's not actually the next code block, but I think it's the one after that. Determines if the Cartesian point is further from 0, 0 than another Cartesian point. Okay, or the no, not or, the distance is the same. It's this one here. Determines if a Cartesian point is further from 0, 0 than another Cartesian point straight up. All right, so let's define that. So again, it's public, static, bool. It's operator greater than this time, the same two operands. Okay, left and right. Now I've already got the less than defined, so I'm actually going to use less than in my definition for greater than. Okay, so since it's already defined, I'm going to return right is less than left. Okay, so in case you missed that, I've reversed the two operands here. Okay, so logically that makes the same sense. By reversing the operands and using the sign I've already defined, I'm going to get the right answer. Okay, so let's save that and try that again. All right, so it actually runs this time. That's good. And I'm on option number 5, testing the relational operators. Okay, and we can see here that okay, actually I should go back to program here. So if point A is less than point B, it writes that it's less than. They're not less than, okay, even though they're, you might say, oh, -3, that should be less than. It's based on the distance, so I'm not getting any information there at all. Okay, so that's what I would expect. Let's deal with the other operators. Okay, so we'll go back to Cartesian point, and we'll just start filling these in. I'm going to scroll up to just underneath the less than operator. This one is less than or equal to. Okay, so we'll look at the code for that. Okay, again, I don't want to reinvent the wheel, so I'm going to be using the definition of less than in my definition of less than or equal to. Okay, so I have two options really. I could say, return left is less than right, or left is equal to right, because I've got is equal to defined as well. Okay, and that sort of makes sense. The only reason why I didn't do this is because I'm basing less than greater than on one concept, distance from 0, and equality based on exactly x is equal to x and y is equal to y. If 2 points are the same distance from each other, do I want this to come out as true or false? So I have to think about which is actually best, and I have to make it known to my team through documentation which one I actually want to do. So this would be the code if I'm dealing with just the distance being equal. Okay, so something you have to decide. We'll scroll down and we'll deal with the next one, which is greater than or equal to, I believe. Okay, so greater than or equal to would literally be the opposite of less than. So I'm just calling less than and using not to reverse it. Okay, so that basically is my relational operators. Let's save that. We'll go back to main and we will, finish off this method where we're testing the remaining operators. I'll just scroll up so you can see all the code. I just did a copy and paste there and changed the operators as we went through. All right, so let's run this. And again, I'm doing option number 5. Okay, we can see that the 2 points, they're not exactly the same point, but they have the same distance from the origin. So less than or equal to is coming up as that's correct, as well as greater than or equal to. So these are coming up indicating that they're the same distance from the origin, but they're not less than or greater than. Let's change the actual points and see what happens. So let's say I'm going to do, I don't know, 5, 4, for example. We'll run that, kind of arbitrary. So option number 5. So we've got different hash codes. You can see 5, 4 is greater than, meaning it's further away than 3, 4. And of course, since it's further away, it's also further away or equal to in terms of distance from 3 compared to 3, 4. So again, I would have to go through and do more testing just to make sure that everything is working exactly the way I want to. But that gives me just the very basics. I'm relatively sure that those are working out for you. All right. So that wraps up our relational operator overloads. What we're going to be dealing with in the next video is the iComparable and iComparer interfaces and where they come into play and how to use them. Thank you very much.